You might notice something a little different in this video. Yeah, shave the head. It was time. It needed it. But today is not about my haircut. It's about trying to fix something in Golang's strings. Now, Golang has some pretty decent strings compared to other languages like C, where it's just a pointer to characters. I'm not saying that there is anything inherently wrong about the way that strings are implemented in Go. I'm merely saying that there's no clean way to do the methods that we're going to check out today. Right? So, let's dive into it. What we're going to be doing is, I just have a clean hello world here. What we're going to be doing is we're going to try and read a file today. And I think we'll say read file, and that'll take in a path string, and it'll return the contents. Now, we're going to say var file is, we're going to do the function of os read file, and that'll get me a slice of bytes or an error. Taking a path. So var, we're going to say raw content, which is a slice of bytes. Just a bit of scaffolding here. Var read error. And that will be raw, and read error is equal to os read file. Oh, almost forgot. And that'll take in a path. And then we're going to do our quick little error checking. But here's the first problem. What do we do with an error checking? How do we pass a sentinel value that shows not only does this file not have any content, but we can't read the file itself, right? That's what I'm trying to sort of separate, is if you read a file that's empty, it's empty. But how do you know that the file hasn't been, how do you know that the file can't be read, or the function failed in some way, right? Okay, so some of you would say, let's pass error, and some of you would be right. So let's just do an error. Let's keep this simple. We're not going to use any libraries today, I don't think. I don't have this folder set up to use libraries, so moot point. And right, so what we're going to do is we are going to return just a static string. Yep, just a static string. You don't know if it has, when you call this function, you don't know if the string you're returning is empty. You don't know if the string you're returning is static even. You don't know what happened to this string. You don't know if this string has a negative length. Like, you could pass in a negative length string with this. It would be hard to do so, but you can do it. So that's what we're going to fix today. And we're going to say errors.new cannot read file. Oh, that's fine. Else we're going to return the string representation of raw and nil. That's just a basic read function in Golang. So let's call this. We'll say var content string var read error, which is an error, and we'll say content and read error are equal to read file, and the path is test.txt. Now, there is no test.txt on my file system. Oops. There is no test.txt. Can you see a test.txt? I can't. I'm just playing around. So there we have test.txt. But if we do read error does not equal nil, we're going to panic with the error, or the read error, sorry. If not, we're just going to print out the content. And we'll run it. Cannot read file, because there is no file, right? So yeah, we have an error, but we also have a static string. We also have something that you can't get the length of. If I just go to the, or if I just go to the content and say, you know, dot, well, I could split and I can have it to bytes, but to get the length, I have to do length -1, because length is single indexed. I guess I probably should create a test.txt. And we'll say this is a test. Just that is our function. And we still can't read a file. Oh, text. Oh, there you go. All right. So, test.txt, we read the file and its length 14. But if I go here, 15. Is length 1 indexed? 0 indexed? I think length might be 0 indexed. 15. Okay, let's individually count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. No, it is 1 index, so 14 was correct. So yeah, I'm right. I know what I'm talking about. Okay. 14. Can I check if it's empty? Nope. At least not plainly. Length of content is equal to 1, or content is equal to just this empty string. False. So it's true. We have something there. But then if I delete this, yep. And then also you have -1 as your size. So Go strings do not have a cleanly logistical way of working with them at all. It is just, it has no methods, it has nothing. It is a string. It is, you have a list of characters, do with it as you will, not to mention it's heap allocated, which is a whole nother can of worms. So today, I aim to fix that. How am I going to fix that? Well, what I'm going to do is I'm going to add a type. I'm going to add a checked string. And that's going to be a structure. And our structure is going to be, I believe, similar to a string builder, but not. If that makes any sort of sense. So we'll say we're going to make a characters. And that is, you know, I think I'm going to do this in a separate file. We'll call it string.go. Package main. And we'll do this in a separate file. Just so it looks nice and I get my point across. Okay, so we have characters, which are a slice of runes. We have a size, which is a uint64. I like using uint64s for sizes. You can use whatever you want, though. Right, size, and I believe that's it. So we just have size. Yep, okay. So then we'll say func new checked string. And I believe the main way we can do a check string is just a basic check string. Is we can do it by passing in some data. So we'll say data, which is a string, and then just returning the check string. And we'll do our little sort of paradigm of constructing. So we'll say new checked string as a checked string pointer, and is equal to new checked string. Okay, and then check string dot characters are equal to a slice of runes into from a string, or from the data. There you go. Okay, and then we'll check string size 0. And we'll return our check string. Awesome. So now we have a more or less empty string, right? Or actually, no, we could say the length of data minus 1. And that has to be cast to a uint64. Right? But if you noticed, we can't really pass this to a uint. Because if data is 0, is nil, nothing. Right? So I think size is going to equal the length of runes, or the length of characters. Which in that case is just a count of characters, and then we could say minus 1. Right? Yeah, if data, yeah, okay. But now, I kind of want to make this more robust, and I kind of want to check this, right? I kind of want to make this actually checked, right? So what I'm going to do is I'm going to get the length of the data. So we'll say var length, which is an integer. Yeah, is an integer. And that is going to equal the length of data. If the length of data is, I want to say, less than 1, right? Or length of data is less than 1, correct? We want to do, because when we have an empty string, right? When we have an empty string, we're gonna do this, and we say -1 is our length, right? However, when we have a length of 1, we have a length of 0, because it's 1. Okay. Okay, yeah. So if -1, and if that is less than 0, then what we're going to do is we are going to return an exception. And we're going to say an error. And we'll say, then we're going to return nil and an errors.new. That is an underflow error. That is an underflow error. Cannot create an empty checked string. Right? Now we can create an empty string. But we'll get to that in a minute. And then we'll say no. However, else if the length is greater than, was it uint64 max? Let's see here. So we'll say golang uint64 max. Some value. Max.max uint64. Okay, so there is one. Max.max max uint64. Do we not have max? No. Is that a package I need to download? Math.max. Ah, okay. Math, not max. My bad. Overflows. Okay, so we'll say that is a uint64. Length. There we go. Okay. Okay, -1 then. Is then we'll say that is an overflow error. We'll return nil and errors new overflow error. Cannot create a string of length greater than a 64-bit integer. There you go. Now, why do we have this function? Right? Why do we have this function? Is because now we can reasonably deduce that our string is both not of length 0 or not of negative length. And then we can also deduce that it won't overflow a uint64 integer, which is very useful. Very useful. Now, we'll do func new empty string. I think I'm just going to call this a new string. That's fine. A new empty string. And you don't have to pass any data, that's fine. And that's just going to return you a checked string. And we're going to say var checked string, which is a checked string. And that is equal to new checked string. Check string dat characters is equal to nil, and check string dot size is equal to 0. Or I guess I can make, yeah, I can make, well, size of 0. Yeah, I guess we'll make, sure, and we'll return checked string. There you go. So now, why you need an empty uint string? For error checking, right? So now what I can do is return new empty string. New empty string. And you can kind of make this nil if need be. Right? So now with this, we can reasonably deduce that we have a way of creating an empty string. We have a way of making everything not underflow, not overflow. And we have an easy way of locating and appending data. In fact, let me show you. So we'll get a func, we'll get a stir. We'll just say stir for right now, and we'll say that is a checked string. And we'll say append. Yeah, append. And that'll take in an item, which is a rune. Rune in Golang, if you're not familiar, is kind of just like a char in C. It's like the bottom bit of what a character is, and that's all it really is. So it is also UTF-8 and Unicode compliant, I believe. Don't quote me on that. Okay, so let's get rid of this. Let's focus on one thing, and we'll just say stir dot characters append the item, and then stir size plus plus, and there we go. And then what I can do is do func stir with a checked string, and I can do extend, which is going to be I guess a string. Yeah, okay, so we'll do data string, and we'll say we'll do this for right now. Item range of data is, we will say stir append item. There you go. You can append a singular rune. You can append multiple runes. You can append a string. I think that's fine. And then we'll say at. Checked string, and we'll say at. At, I think, will return a rune at an index. Right? So we'll say index, and that is a uint 64, and that will return us a rune. And we'll say, let's see, so we'll say the stir, we're going to return stir characters at index. There you go. And then we could say func stir. I think you guys get the idea. But then check string is we'll return an at, or not an at, a range or substring. Yeah, we'll do a substring. And that can have max or min, max, which is a uint 64. These are indexes, and that'll return a string. And we'll return the stir characters at the min to the max. So now we have a substring. But where this really shines is now we can get a size and we can get an empty boolean, right? So what I want to do is have a string. I don't necessarily need a pointer for this. We're just reading size uint 64, return stir size, and then check string is empty. It's going to return a boolean. Return the length. Here's a little bit where you're going to have to do the dirty work. Return the length of stir characters does not equal 0. Is equal to 0, or stir characters is equal to nil, or stir size is equal to 0. There you go. I think, or the string of stir characters is equal to an empty string. That's truly what you want this library for, is to check if a string is empty, check if a size of a string, right? Also size, maybe you want to get the size of a file, right? If I want to get the file size, all I got to do now is construct our string here. So we want to, instead of returning a string, we want to return a checked string. And we're going to say empty string. And we're going to return checked string, new string from the string of raw. There you go. Oh, actually, this returns an error. Okay, so that's fine. That makes our lives easier, which is great. And then content gets a checked string instead of a string, right? So if we error, if there is no string, what I can essentially do is say we can do print line content size. What's the content size? Main go check string new empty string. They're all public. I know in Golang it's kind of, main can't do anything, but I guess, okay, so we'll do, I'll make a package string just to get around that, but it's all the same. And string is string. There you go. And then whoops. And this is string. There you go. And we'll say string check string. We'll do checked. Yeah, just a little bit of housekeeping, that's all. Checked. Ah, that's right. Okay, so we have no go mods. We'll do go mod init string, I guess, or strings. No, checked. Yeah, checked I think is fine. There you go. Okay, that's good. And then checked. And then we could say just string, which is going to be, okay. So in main, we'll say checked string. Oh, my nose is itchy. Is checked new empty string. Checked new, not empty string. We want to do a new string. There you go. Okay. And we'll say that is a checked string. And then we can get the content size. Whoops. 14. Which, as we already went through manually, we checked. So that's correct. We have a size of 14. And then FMT, print line, we'll say content is empty. We'll see if the content's empty. False. It's not empty as far as I know. And then we'll say print line is content. We'll get a substring. We'll get a substring of 1 to 4. This. Oh, I should have said 0 to 4. Yeah. Here, let's say 0. This. That's the first word. THIS. 4. That is the power of check strings. That's what I'm getting at. Is you can do all of this. And it's so clean. Look at this. The only really dirty part is when we're checking for if it's empty or not. That is the power of a check string in Golang.